Make it right now. Woo! Classic song here, ladies and gentlemen. A little Jurassic 5 and Dave Matthews Band. Can't beat it. Jurassic 5, classic band. Alright, if you've never heard of them or listened to them, make sure you get out there and do that. Dave Matthews Band, also, obviously a classic. Get out and listen to them too. Okay. Here we go. So we're talking about today we're talking about exponential functions and their graphs. All right. Yesterday we did that little exploration about exponentials. Okay. So today we're going to look at the graph and then we're going to transform said graph. Before we do that, though, I want to review our transformation types. Hold on a second, I gotta go get something. Sorry about that. Someone was knocking at my door. Here we go. Let's review our types of transformations here. Whoops. First off, if I have a number attached to the front of f of x, is a little review from our first unit, if you remember all the way back then. If it's outside like this, okay, if it's outside the parentheses out in the front, I'm going to multiply y values. Y values. Holy buckets, by. Okay. All right. If it's on the inside, remember, if it's on the inside, it affects our x, and we do the opposite. So if it's standing next to it like that, that means I'm going to divide x values by a. When it's attached on the outside, like that, okay? If it's on the outside, remember, inside affects the x, the outside affects the y. So that means I'm going to shift. Oh, that was supposed to be orange, but whatever. Up or down. Okay. If it's attached on the inside, all right. So attached on the inside like that, with the green there. That means I'm going to, let's make it orange. I know some people are OCD like that, like me. Okay. Attached on the inside, so plus h, that means I'm going to shift left or right. In this case, if it's plus, I do the opposite, so I would go left. H. Again, this is a review from the first unit. Don't forget about it. If I'm being multiplied on the outside, we did this more than we did the second one. And this is what you're going to see more. Then I'm going to reflect over the x-axis. And this reflects over y. All right, so let's holy buckets. Wow. Okay. Start over. Let's apply it. What? All right. Sorry about that again. Could be my last time I pause. Could not be. All right. So we're talking about exponential functions. Okay. Remember, in an exponential function, obviously the x right here, this is our exponent. We refer to b as our base. All right. And we call that b, just like it says. Okay. If b is greater than 0 or b does not, where b does not equal 1, and x is any real number. All right. So why the restrictions on b? Well, if b is less than 0, if it's a negative number, then there's going to be a reflection. Okay. If b equals 1, then y equals 1. And I'll explain what I mean there. Some key features. All right. No matter what the base is of your exponential function, there's going to be a y-intercept of 0, 1. And these key features are the most important part of these graphs. All right. These are VIP right here. All right. It's going to be a y-intercept of 0, 1. Well, why is that? Why is that? Well, if you think about this, if I do 2 to the 0, that's going to be 1. If I do 3 to the 0, that's going to be 1. If I did 4 to the 0, that's going to be 1. So the reason is because anything to the 0 power is 1. Right? No matter what our base is, anything to the 0 power. So when x is 0, no matter what, I'm going to get an answer of 1. My output will be 1. If my input is 0, my output is 1. And the first ordered pair that you're going to have, no matter what, prior to a shift, is 1, comma, whatever your base is. So I'm gonna write B for my base. Remember that B equals base. Okay. And I'll show you what that means in a second here. Another key. There's three key features: the y-intercept, the point, and there's a horizontal asymptote. This horizontal asymptote can change depending how it shifts up and down, depending how our graph shifts up and down. So every time you graph something, all right, you'll have the horizontal asymptote. I'll have the point 0, 1, and I'll have the point 1 comma b, whatever that b value is, and it'll look something like this. Now, obviously, after I shift it and do things like that, this is going to change. Okay. This is going to change. If I shift it up, my horizontal asymptote will move up, my y-intercept move up, everything moves up 1. If I shift it left, doesn't affect my horizontal asymptote, but it does affect my points. Okay, so when you're graphing problems like this, all I ask is that you have these three key features. Shift these key three holy buckets. Trying to say that 10 times fast. All right, so I'm just going to stop there because I'm just embarrassing myself. So we're going to graph by hand on the same graph. Say domain and range of each. Identify the asymptotes and intercepts. So I'm going to do f of x equals 2 to the x first. And we're going to deal a lot with these two, 2 to the x and 3 to the x. Those are our two main exponential functions that we'll talk about just to keep it simple for ourselves here. All right, so if I think about my graph, all right, well, I know that if I have my x comma y, if my input is 0, my output is 1. If my input is 1, my output is my base, so 2. So those are my 2 points, 0, 1, and 1 comma 2. My horizontal asymptote, which I'll abbreviate HA, is going to be y equals 0, since there wasn't a vertical shift. Okay, we always write our horizontal asymptotes as dotted lines. All right, our domain. I can plug in any x value, whether that's 1, -1, -100, and still have an output for y. So my domain is going to be -infinity to infinity. My range will change. My range will be from my horizontal asymptote, which is 0, to infinity. And again, these all correspond. This will match that. Okay? Always. And I don't like using the word always. If you know me, I don't like saying always. Oh my goodness. All right, so now I want to graph, if I can. Hold on. There it is. All right, so I'm going to graph this. Okay, and it's going to look something like that. All right, roughly speaking. Okay, it'd probably go up to here, but that's okay. All right, so now let's do 3. I'm going to make 3 of the x in red, and I'm going to graph that too. I got x, and I got y. 0, I get 1. If I plug in 1 now, I get 3. So 0, 1, still a point, but 1, 3 is our next point. And there's obviously some overlap. That's going to increase quicker. Horizontal asymptote. Was there a vertical shift? No, there was not. So our horizontal asymptote is still y equals 0. Domain. Exponential function. I can have any input and get an output. So -infinity to infinity. And my range always matches my horizontal asymptote. So from 0 to infinity. All right. On this next one, okay, it says graph f then g. I'm just going to graph g. All right. I just want to keep it simple so I don't have too much going on. Okay. So let's think about this. That +3 is next to our x. Okay. Since the +3 is next to our x, that means I'm going to shift it going back here, just like it was next to x, shifts it left and right. So remember, when it's next to the x, I mean it's on the inside, so this is kind of the inside right here. I do the opposite, so I shift that left 3. So what were my characteristics of 2 to the x? Well, I had the points 0, 1 and 1 comma 2. All right, so I take that 0, 1, which was right here, and shift it left 3. 1, 2, 3. There's my new point. I had 1 comma 2. 1, 2, 3. There's my next point. Okay. Was there a vertical shift? No. So my horizontal asymptote is still y equals 0. Okay. Domain, was that affected? No. So it's negative infinity to infinity, and the range always matches the horizontal asymptote, so that's from 0 to infinity, and then go. Remember, how do I know that it's these 2 points? Well, you're always going to start with 0, 1, and I'm always going to start with 1, comma, whatever our base is. Our base here was 2. All right, so now we're going to double shift it. Okay, so again, I started with 0, 1, and 1, 2. All right, so now I'm going to shift those points. What am I going to do? Well, if it's minus 3, that means I'm going to go right 3. That's a B. I'm going to go right 3 and then down 5. When it's on the outside, it affects my y. I go up and down, and it stays the same. So I'm going to start at 0, 1, and I'm going to go right 3 and down 5. Why don't you guys try and graph this number 2 on your own? Go for it. All right, so I shifted each point. I took 0, 1 and went right 3 and down 5, and I got here. That's 3, looks like negative 4. And then I went from 0 to, or excuse me, from 1, comma 2, and went right 3 and down 5 to get 4, comma, what is that, negative 3. All right, so now, remember I constantly refer back to here. There was no vertical shift, so our horizontal asymptote was y equals 0. Same thing for both of these. No vertical shift, so our horizontal asymptote didn't change. Here, there is a vertical shift. I go down 5. So that makes my horizontal asymptote y equals negative 5. So I make my dotted line at negative 5, like this. And the key with the horizontal asymptote is that your graph will never cross that line. All right, and then you just draw a rough sketch like that. Okay, let's look at this one. Since the base is 3, all right, my 2 points I'm gonna start off with is still 0, 1, but my other point I'm gonna shift is 1, comma 3. All right, so what is the shift here? The shift here, if I have a plus 4, it's attached to the x. It's the opposite, so I'm gonna go left 4, and then it's a plus 3 on the outside, so I'll go up 3. So why don't you take these 2 points and shift them for me? All right, so those are my 2 new points. I got negative 4, and then negative 3, 6, it looks like. Okay. Remember here, look, there's a vertical shift up 3. So my horizontal asymptote is y equals 3. So I'm going to draw that line in for myself. All right, and then I'm just going to connect my dots. And boom, I'm done. Okay. I want to review some exponent rules. Okay. Rules of our properties of exponents, and we're going to come back to these in a little bit. If I multiply if I multiply, same base like this, what do I do with my exponents? If it's x squared times x to the third, it'd be x to the fifth. So it's really b to the x plus y. Remember, when you multiply, you add. But when I multiply, I add. Then when I divide, I subtract. If I have a negative exponent, how do I make it positive? I flip it. Anything to the 0 power is 1, and then the first power is itself. All right. Here, if I raise a power to a power, so you can think about this as a to the first, b to the first, that becomes a to the x times b to the x. Power to a power again, it's b to the x times y. And here I can split it so it's a to the x over b to the x, like that. Okay? So when you see this, like 1 over b to the x, know that it's really b to the negative x. Well, what's that going to do? That's going to flip my graph. That would be something like this. Excuse me, I also realize this isn't on your sheet, but that's okay. I just want to talk briefly about it. This is really 2 to the negative 1 to the x power, all right, which is the same as 2 to the negative x. So that's going to reflect over the y-axis. Remember, if it's attached to the x, it reflects, and that would just look something like that. I know I did that quick, but if your exponent's negative, it flips over the y-axis like that. All right, that's it for today. Deuces.